Algebra 2, Chapter 5, Section 8, the quadratic formula. In this lesson, we're going to learn to solve equations by the quadratic formula and determine types of solutions by using the discriminant. Okay, so we can actually derive a formula for solving quadratics just by completing the square with what we have learned. So let's set a quadratic equation in standard form. So I got ax squared plus bx plus c equals 0. Let's solve for x. So the first step is let's subtract c to each side. Alright, I do that. I get ax squared plus bx equals negative c. All I did was subtract c to each side. Okay, the next step to solve for a quadratic is we've got the variables to one side of the equation. Now divide by that a value, okay, to get the a value to be 1. So I'm going to get x squared plus b over a, I've divided everything by a, equals negative c over a. Okay, now let's find that our b value is b over a. So my b over 2 value, we're going to complete the square here, is just b over 2a. And that value squared becomes b squared over 2a times 2a would be 4a squared. Okay, so I'm going to complete the square. So to do that, I have to add that value to each side of the equation, b squared over 4a squared. So I'm going to add b squared over 4a squared. Looking at the left side now, that is what we call a perfect square trinomial. So we can rewrite that basically saying x plus our b over 2 value, which is b over 2a, squared, perfect square trinomial. On the right side, all I have is b squared minus 4a squared, you see here, b squared over 4a squared minus c over a. Now I want to add those terms together on the right side, but I have to get the denominators to be the same. So I need to multiply the top and the bottom of one side to be the least common denominator, which would be 4a. So I'm going to get it to be equal to b squared minus 4ac all over 4a squared. See how I combine like terms? And then since the denominator is the same on both, I can combine it. The left side's still going to be x plus b over 2a squared. It should start to look something familiar to what you're used to. So now I got to square root each side. Okay, when I do that, I get x plus b over 2a equal to plus or minus the square root of b squared minus 4ac over the square root of 4a squared. Now subtract b over 2a to each side, so I get x equals negative b over 2a plus or minus the square root of b squared minus 4ac over, now let's look, what is the square root of 4a squared? That would just be 2a, right? So we can put that over 2a. So I have x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Since I have 2a on both terms on the right in the denominator, I can say just x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there we're able to prove the quadratic equation. So now, with this equation, by completing the square, we can solve any quadratic equation just by putting it in standard form, setting it equal to 0, and then plugging in our b and a and c values where needed. So let's go. So our equation, which we just proved on the previous page, is negative b plus or minus the square root of b squared minus 4ac over 2a. but it has to be with the ABC values in standard form. So now, using it in an equation, so I have negative 3x squared minus 5x equals 2. Step 1, write it in standard form. Step 2, go ahead and write down the values for a, b, and c. Step 3, write down the quadratic equation. Step 4, just sub it in. Step 5, simplify and do the math. Pretty easy. Okay, look at that example, fill it in on your notes if you need to. Okay, let's move on. So use the quadratic formula to solve 3x squared minus x equals 4. Step 1, 3x squared minus x minus 4 equals 0. Our a value is 3, our b value is negative 1, and our c value is negative 4. So it's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. So here we go. Negative b, so negative 1 is positive 1, plus or minus the square root, negative 1 squared is 1, minus 4 times our a value times our c value, all over 2 times our a value. So that's going to be 1 minus negative 48. So that's going to be 1 plus or minus 1 minus negative 48 is 49. 2 times 3 is 6. So that's going to simplify to 1 plus or minus 7 over 6. So 1 plus 7 is 8. So one answer is 8 over 6. The other answer is 1 minus 7, be negative 6. So it'd be negative 6 over 6. So those answers become, we can simplify that to 4 over 3 and negative 1. And again, the order does not matter. Okay, next example. Finding complex solutions. We'll just follow along in the book. It gives you an equation. Step 1, write it in standard form. Step 2, identify a, b, and c. Step 3, substitute in the quadratic equation. Simplify, take your steps, and follow along. Pretty easy stuff. Okay. We're not worried about 2b right now. Use the quadratic formula to solve. Negative 2x squared equals 4x plus 3. Okay, well, I'm going to set it equal to 0, so I'm just going to move the negative 2x over. So I'm going to get 0 equals 2x squared plus 4x plus 3. So there's my a, there's my b, there's my c. So negative b plus or minus the square root of our b value squared, 4 times 4 is 16, minus 4 times a times c. So 4 times 2 is 8. 8 times 3 is 24. All over 2a. Well, 2 times 2 is 4. So that's going to simplify to negative 4 plus or minus the square root of negative 8 over 4. Alright, let's work on the square root of negative 8. Well, that's the same thing as the square root of negative 1 times the square root of 8. So that's 1. And 8 factors to 2 times 4, which factors to 2 times 2. So I have a pair of 2's. So I can rewrite that as 2i square root of 2. So here we go. So this is going to equal negative 4 over 4. Again, all I'm going to do is separate this. Plus or minus 2i square root of 2 over 4. So I can rewrite that as negative 1 plus or minus I square root of 2 over 2. Answer would be A. Okay, 2b, graph the related quadratic function. Okay, y equals 2x squared plus 4x plus 3. Well, we know first thing is the y-intercept is 3. Okay, we know the x value is not 0 there, so we know it's going to go up. So it won't be b, it won't be a, it won't be c. So the only one it could be is d. The graph does not intersect the x-axis. How do we know that? Because when we actually do the math, we're going to find out we have an I value. Okay, we have an I. So when we have an I, that tells us it does not have a real solution. So our parabola does not cross the x-axis. So let's look at it real quick. Let's just plug it in. 2, 4, and 3. That's what we used in the last example, I believe, right? 2, 4, and 3. So using this example, since we have I in it, we know it cannot cross the x-axis. Okay, we're going to skip that example and go on. Using the quadratic, we can actually solve, and then we can put it in radical solution, and we can round it. Again, that's just plugging in. Remember, step 1, always set it equal to 0 so you can solve. So this one would be 4x squared minus 8x plus 3 equals 0. So if negative b plus or minus the square root of b squared minus 4ac, 4 times 3 is 12, 3 times 4 is 48, all over 2a. So this is going to equal 8 plus or minus the square root of 16 over 8. So that's going to be 8 plus or minus 4 over 8. So my answers are going to be 1/2. 8 minus 4 is 4 over 8 is 1/2. 8 plus 4 is 12 over 8 would be 3/2. So 1/2 and 3/2. And B, again, just plug it in and solve. Now, the last part of this lesson should be the easiest part. Quadratic equations can have real solutions or complex solutions. You can determine the type and number by finding the discriminant. Remember, we talked about quadratics to a power of 2, so there's a possible of up to 2 solutions. All right, the discriminant, the things underneath the radical sign, b squared minus 4ac, tells us a lot about the quadratic. So the discriminant is b squared minus 4ac. Don't forget that. If the discriminant is positive, there are 2 real solutions, and it's going to cross the x-intercept twice, either up or down. If it is 0, if the discriminant is equal to 0, the vertex is on the x-axis. The vertex is on the x-axis, okay? And if the b squared minus 4ac value is less than 0, it does not intercept. There are no real solutions, or there are 2 imaginary solutions. Easy stuff for us, okay? Moving on, using the discriminant. So I have this equation, x squared plus 6x plus 8. Identify my ABC values, and the discriminant is b squared minus 4ac. All right? It's 36 minus 32, it's 4. So it has 2 real solutions. It's a positive number. You actually don't even have to solve if it doesn't ask for it to tell if it's a positive solution. So let's buzz through these. Determine the type of the number of solutions. Okay, there's my A, B, and C values. So it's b squared minus 4ac. So my B value is 6. So 6 squared is 36 minus 4 times A is 1. My C value is 9. So it's 36 minus 36. That equals 0. So there's 1 real solution. So the answer is B. So that tells us it is on the x-axis. The vertex is on the x-axis. Determine the type and number for this one. Okay, A, B, and C. B squared minus 4 times A times C equals negative 4. So there's 2 imaginary solutions. Okay, 1 imaginary is not even a possibility. Okay, moving on. So we got word problems. Suppose a hockey player makes a scoop that releases the ball with an upward velocity of 34 feet per second. All right, the function h is negative 16t squared plus 34t. Models the height h in feet of the ball at the time t seconds. Will the ball ever reach the height of 20? Okay, so we're just going to plug it in. We're trying to find the height of 20. So we were given this equation. We plug in h of 20 and we solve. All we got to do is find the discriminant. If the discriminant is positive, we're good. We know it exists. If the discriminant's negative, we know it doesn't. It's negative, so that means it's not going to reach the solution. It's not going to reach the height. Okay? And again, we'll look at this real quick. You're going to want to pause it here because we're going to run out. Read this out loud. Positive square number, positive